Welcome to solverfy.
Okay, so we have a classic stoichiometry problem. We've been given some reactants, sodium chloride and silver nitrate, going to silver chloride and sodium nitrate. And what we need to determine is that if we have 1.6 grams of sodium chloride and 3.5 grams of silver nitrate, how many grams of silver will we get, or silver chloride will we get, and how many grams of sodium nitrate will we get? So the first thing that we need to do is find out how many moles of each reactant we have. Well, the very first thing that you want to do is balance your reaction, but as it turns out, this is already balanced because every coefficient is simply 1. So if it's not balanced, be sure to balance it. But in our case, they've made that easy. So how do we get the moles of sodium chloride? Well, we use the molecular weight, right, which tells us that in every 1 mole of sodium chloride, we have 58.44 grams. So for each of these, we'll simply divide their given mass by the molecular weight, which means for sodium chloride, we have 1.6 divided by 58.44. Put that into my calculator, and I get 0.0273 moles. And for silver nitrate, I've got 3.5 grams divided by the molecular weight of silver nitrate, which is 169.87 grams per mole. All right, so I'll divide by the molecular weight, 169.87, and I get 0.0206 mole. Note that I'm keeping one more sig fig than we have been given in our problem statement. You can keep as many as you want, just be sure when you get to the end of the problem, you go back down to 2, and it's always best practice to keep at least one more than you have in your problem statement to avoid any rounding errors. Okay, so at this point, what we need to determine is which of these is the limiting reagent, right? So in this case, that's silver nitrate. And what that means is that if we have 0.206 moles of silver nitrate, then we can only react that with 0.206 moles of sodium chloride, because we cannot make silver chloride unless we have silver and chloride, right? So determine your limiting reagent. In this case, it's silver chloride or silver nitrate, and then know that that is the number of moles you'll get in your products, and that this value is basically irrelevant. Okay, so what we found out is that we have 0.0206 moles of silver nitrate, which means that because the stoichiometric coefficients on everything here is 1, that we will end up with 0.0206 moles of silver chloride and 0.0206 moles of silver nitrate. And so all we have left to do now is to use the molecular weight to go from moles to grams, right? So the molecular weight of silver chloride is 143.32 grams per mole. And for silver nitrate, or sodium nitrate, it's 84.9947 grams per mole. 9947, sorry about that. Okay, now to go from grams to moles, we divide it by the molecular weight. To go from moles to grams, we will multiply by the molecular weight. So grams of silver chloride is going to be 0.0206 mole times 143.32 grams per mole. Moles cancel, and we get our final answer in grams of 43.32 times 0.0206, and I get 2.953 grams. And for silver nitrate, we get 0.0206 mole times, this time, the molecular weight of silver nitrate, 84, or sodium nitrate, 9947 grams per mole. Moles cancel, and our answer is, let's see, 84.9947 times 0.0206 equals, give me a second here, 1.751. And at this point, we can round our answers. That's for silver nitrate. We could round our answers to 2 sig figs. So we will get, for silver chloride, 3.0 grams. And for silver nitrate, sodium nitrate, we get 1.8 grams.